So, ladies and gentlemen, in this discussion, we are going to be looking at more questions on induction motors. So, we are told to compare a squirrel cage and the slip ring three-phase induction motors as used in the industry. And the question says a three-phase 8-pole squirrel cage induction motor connected to a 60 Hz line possesses a synchronous speed of 900 RPM. The motor absorbs power equivalent 40 kilowatts, and the copper and iron losses in the stator amount 5 kilowatts and 1 kilowatt respectively. Calculate the torque developed by the motor. Now, let's begin with comparing the squirrel cage and the slip ring induction motors. So, in terms of construction, the squirrel cage consists of short-circuited bars with no external connections, whereas the slip ring has windings connected to external slip rings. So, in other words, there are external connections on the slip ring motor. So, the starting for squirrel cage it has simple starting, and we can use direct online starter. Then slip ring can use external resistances for high starting torque, and that's why sometimes you find this one is at a better advantage because it can start with maximum torque that is always actually required in areas that use this motor in cranes, elevators, or lifts, in the mills. So very important motor. So for torque, there is moderate starting torque, but for slip ring motors, we have a high starting torque due to external resistance. The squirrel cage motor requires less maintenance due to simple construction, whereas there is higher maintenance due to slip rings and brushes in the slip ring. These brushes get worn out and they have to be replaced, thereby putting extra maintenance costs slightly higher on the side of the slip ring motor. Then they are also used, we are talking about now applications, the applications that they are used in applications where low maintenance is needed. For example, fans, pumps, and these are used in applications requiring high torque, that is cranes, lifts. So this one has a lower cost, this one has a higher cost due to additional components. So let's look at this problem. A three-phase 8-pole squirrel cage induction motor where is connected to 60 Hz, possesses a synchronous speed of this and absorbs this amount of power. So this is part B. The power input or absorbed, we've got 40 kilowatts. Stator loss, stator copper plus iron losses amount to 5 plus 1, giving us 6 kilowatts. So that means the power developed by the motor is going to be 40 minus 6, giving us 34 kilowatts. So that means this is the power that is going to generate the torque that we need. So we need to know that power is equal to torque omega. But remember that we are not provided with the slip, and therefore the omega that we are going to use is the synchronous speed. So our torque is going to be power, which is 34 kilowatts, divided by 2 pi ns divided by 60. This is 34 times 10 power 3 times 60 divided by 2 pi times 900. So the torque that is required or the torque that is developed, is going to be 360.75 Newton meter. So what we have to understand in this calculation is that we have to note something, is that this is the torque generated as long as the power developed is 34 kilowatts. So it is independent of the speed of the motor.